Now that we know how to find the angle between two vectors, we're going to be able to determine whether two vectors are parallel, perpendicular, or neither. So let's talk about parallel vectors. Okay, so what does it mean for two vectors to be parallel? They don't need to coincide. They don't have to have the same length. What has to happen is that the vectors must have the same direction. Okay, so I'm just drawing a pair of parallel vectors here. Okay, or I'm trying to. Okay, so these two vectors, like I said, they don't coincide. They don't have the same length. All that matters with parallel vectors is that they have the same direction. Okay, so underneath parallel vectors, there's a little more information here. It says two vectors u and v are said to be parallel if there is a non-zero scalar alpha, so that vector u is equal to alpha times vector v. Okay. In this case, if you're dealing with parallel vectors, the angle between the two vectors is either 0 degrees or 180 degrees. Okay, so keep that in mind. If you did put them together, if you did line them up so that their initial points coincided, the angle between them would be 0 or 180 degrees. Okay, that would prove that they are in the same direction, or you can have them in opposite directions. Okay, so that's where the 180 degrees comes in. Okay, so perpendicular vectors. There's a fancy name for perpendicular, that's orthogonal. If you are asked if two vectors are orthogonal, that just means are they perpendicular? Okay, so we know from regular geometry class what perpendicular or orthogonal vectors are going to look like. Okay, so they would have to meet at a right angle. Okay, so this might be a pair of this might be a pair of orthogonal vectors that I'm drawing right here. Okay, so the angle between them has to be 90 degrees. Okay, so that's a quick sketch of some vectors that are orthogonal. Okay, if the angle theta between two non-zero vectors u and v is 90 degrees or pi over 2 radians, the vectors u and v are called orthogonal. Okay, since the cosine of 90 degrees is equal to 0, it follows from the formula cosine of theta is equal to u dot v over the magnitude of u times the magnitude of v, that if the non-zero vectors u and v are orthogonal, then u dot v has to be 0. Okay, so let me elaborate on that. Okay, so we just learned that if you're trying to figure out the angle theta between two vectors, you're going to use the formula cosine of theta is equal to u dot v over the magnitude of u times the magnitude of v. Okay, so this is the formula that you would be using. Okay, so if the vectors are orthogonal or perpendicular, then that's going to mean that theta has to be 90 degrees. Okay, because the angle between them is theta. If they're perpendicular, that angle has to be 90 degrees. Okay, well, the cosine of 90 degrees is going to be 0. Okay, so that would imply, so I'll write here the cosine of theta, the cosine of 90 degrees is 0. Okay, using this formula, okay, the cosine of 90 degrees would be 0. Okay, that would make this right hand side u dot v over the magnitude of u times the magnitude of v. That would equal the cosine of 90 degrees, which would be 0. Okay, so you would have to solve this formula. Okay, so you have a fraction equal to 0. The only way a fraction can be equal to 0 is if the numerator is equal to 0. You can't have 0 in the bottom because you can't divide by 0. Okay, so for the only way this can happen is if u dot v is equal to 0. Okay, so this is an important idea here. It's summarized in the box. Two non-zero vectors u and v are orthogonal or perpendicular if and only if their dot product is 0. Okay, if the dot product is 0, that means the right side of this formula is 0. the cosine of what angle is 0? Well, 90 degrees. Okay, so keep that in mind. If you do the dot product of two vectors, you don't even have to draw it out. If you do their dot product and you get 0, boom, you know they're perpendicular. Okay? All right, so let's do some practice with example 10. Okay, we are going to determine whether the given vectors are parallel, orthogonal, which means perpendicular, or neither. Okay, again, it's not a requirement to draw things out, but having a visual does help you gauge whether your answer is correct or not. Okay, so we are going to start with part A. Okay, we've got vector V, which is 2i minus j, and we've got vector W, which is 3i plus 6j. Okay, I'm going to start by writing these guys in component form. So vector V is 2, negative 1. Vector W is 3, 6. Okay, I'm going to graph it out, okay, just to get a visual. So vector V has an initial point at the origin. It has a terminal point at 2, negative 1. So it's a teeny tiny vector. So I'm drawing always from the initial point to the terminal point. Okay, so it will look like this. This is going to be vector V. And then we've got vector W, which also has an initial point at the origin. Its terminal point is at 3, 6. So that's going to be right here. Okay, so here's vector W. Okay, and we're trying to figure out what this angle is, theta. Okay, it looks like it definitely could be 90 degrees. Okay, but we've got to make sure. Okay, so we're going to use our formula on all of the examples in example 10. We're going to be using this formula. Okay, so there's some back work we're going to have to do here. Okay, for this particular example in part A, we've got to figure out the dot product. We've got to do V dot W. We need the magnitude of vector V, and we need the magnitude of vector W. Okay, so let's do all of this and then we can plug everything in. Okay, I'm going to start with the dot product. V dot W. Okay, that is going to be, let me actually move this down. V dot W. Okay, to do the dot product, the answer is going to be a number. I need to multiply the corresponding components here. Okay, so I'm going to get 2 times 3 if I multiply the horizontal components together, and then I'm going to multiply the vertical components, negative 1 times 6, add the results. This is going to be 6 minus 6. The dot product is 0. Okay, automatically, since the dot product is 0, we can conclude that these vectors are orthogonal. Okay, anytime the dot product is 0, okay, the angle between the two vectors is 90 degrees. Okay, our sketch seems to indicate so. Okay, if you didn't, remember this fact, you could have gone all the way. You could have computed the magnitude of vector V. Okay, that's going to be the square root of 2 squared plus negative 1 squared, which is the square root of 4 plus 1. So that's the square root of 5. Magnitude of W is going to be the square root of 3 squared plus 6 squared. This is going to be the square root of 9 plus 36. Okay, that's going to be square root of 45. Okay, and then you could pop this all into the formula. Okay, the cosine of theta is going to be V dot W over the magnitude of V times the magnitude of W. Okay, so we would get that the cosine of theta is equal to V dot W, that's 0, over the magnitude of V, that's the square root of 5, times the magnitude of W, that's the square root of 45. Okay, so we could pop this into a calculator. Okay, we'd have to solve for theta here, so we'd have to take the cosine inverse of both sides. So theta would be equal to the cosine inverse of this fraction. Okay, 0 divided by whatever this denominator is, 0 divided by some number is going to be 0. Okay, so if you went to your calculator and you did cosine inverse of 0, you're going to get 90 degrees, okay? Even if you did this all the way out, okay? If I did the cosine inverse of 0 divided by the square root of 5 times the square root of 45, okay? If you did the whole thing out, okay? You're going to get that the angle, because we're in degrees here, there's 90 degrees between the two vectors, okay? So they are orthogonal, okay? Let's try the next pair of vectors. Okay, so here in part B, vector V is the square root of 5 times I minus 2j, and vector W is negative 5I plus 2 square root of 5j. Okay, in component form, here we go. I am going to look at the square root of 5 because I'm going to try to graph this out, but I need a decimal approximation. The square root of 5 is about 2.23, so I'm just going to round it here, 2.23, negative 2, and then vector W is negative 5, and then I need an approximation for 2 square root of 5. So here, this is the square root of 5. I just need to multiply it by 2. That's going to be about 4.47. Okay, this is just for me to graph and get a visual. When I'm doing the actual dot product, I need to use the full decimal approximation or just use the radical form. Okay, so vector V is going to start at the origin. Its terminal point is at 2.23 negative 2. So that's about right here. Okay, so this is going to be vector V. And then I'm going to graph vector W. It begins at the origin, and then its terminal point is at negative 5, 4.47. So that's going to be about right here. Okay, so this is going to be vector W. All right, so when you're looking at it, you know, it could be a straight angle. I didn't draw it so well, but we're trying to compute this angle between them, okay? To decide whether it is a straight angle or not, we need to use the formula, okay? So again, we're going to have to do this. We're going to have to apply this formula right here. The cosine of theta is equal to V dot W over the magnitude of V times the magnitude of W. Okay, so let's do that here. Okay, I'm going to start with the dot product, and again, I need to use the exact answers here. So this is going to be the square root of 5 times negative 5. If you multiply the horizontal components, add the product of the vertical component, so that's going to be negative 2 times 2 square root of 5. Okay, let's see what this gives us. This is going to be negative 5 square root of 5 minus 4 square root of 5. Okay, so this is going to be negative 9 square root of 5. Okay, you can combine terms with radicals as long as you have the same radical. Okay, all right, so that's the dot product. Okay, we definitely don't have orthogonal vectors because the dot product is non-zero. Okay, let's get the magnitudes here. The magnitude of V is going to be the square root of the horizontal component squared plus the vertical component squared. Okay, so it's going to be this. So if we simplify this, this is going to be the square root of, underneath the square root of 5 squared is 5. And then we're adding negative 2 squared, that's 4. Okay, so this is going to be the square root of 9, which is going to be 3. Okay, so that's nice. Now we get the magnitude of vector W. This is going to be the square root of the horizontal component, so negative 5 squared plus the square of the vertical component. So this is going to be 2 square root of 5 squared. Okay, be careful on the simplification process here. Negative 5 squared is positive 25, and then we're adding. When you square 2 square root of 5, you have to do 2 squared, that's 4, times the square root of 5 squared is 5. So this is going to be the square root of 25 plus 20, which is going to be the square root of 45. Okay, all right. So let's go ahead and plug all of this into our formula. I'm kind of out of room here, so I'll do it maybe on the other side of the picture. Okay, so we know the cosine of theta has to be equal to v dot w. So the dot product, we said the dot product is -9 square root of 5. Okay, that's got to be divided by the product of the magnitude. So this is going to be 3 square root of 45. Okay, so we're going to go to our calculator to figure out what the angle is. To solve for theta, we need to take the cosine inverse of both sides. So we're going to punch in cosine inverse of this quantity, -9 square root of 5 over 3 square root of 45. Okay, so let's go and see what we get. Okay, so we're going to get the cosine inverse of -9 square root of 5. All of that needs to be divided by 3 square root of 45. Okay, make sure the entire denominator is in parentheses if you have an older calculator. It should look like this. Okay, here's the angle. We get 180 degrees out exactly. Okay, that's why you needed to use the radicals instead of the approximations. Okay, so like I said, when I drew this out, it looked like it could be a straight angle, but I wasn't quite sure. Maybe it was like 178 point something. Okay, but we have confirmed that this is definitely a straight angle. Okay, so we can go ahead and say, since this is a straight angle, these guys are parallel. Okay, even though they are pointed in opposite directions, they are considered to be parallel here. Okay, because there is some number that you can multiply one of the vectors by to get the other. Okay, think about it this way. Okay, if I were going back to my sketch here, if I align myself with vertical W, okay, there's something I can multiply it by to reverse its direction, and then they would be pointed in the same direction. Okay, so if you went back to the definition of parallel vectors, okay, let me go back to that back on the previous page. If we go back to page 9, okay, two vectors are considered to be parallel if there's a scalar that exists so that you can multiply, do scalar multiplication on one of the vectors and get the other. Okay, also it's defined, two vectors are said to be parallel if the angle between them is either 0 degrees or 180 degrees. Okay, so these two vectors, there's 180 degrees between them, so we do have parallel vectors. Okay, all right. Let's take a look at part C. Okay, so we can go ahead and sketch out our vectors here, and then we can look at the angle between them, figure it out. Okay, so first we've got vector V, which is 3, -4. Okay, so if I graph this guy, it's going to have an initial point at the origin, and then 3, -4 is going to be the terminal point. Okay, so here is vector V. And then I'm going to graph out vector W. Okay, so W has components 9, -12, so I'm going to be a little bit off the grid. Okay, so here's 9, -12. Okay, so about right here. Okay, so this vector has an initial point at the origin. Its terminal point is at 9, -12. So that's going to be right here. Okay, you can pretty much tell from the graph that these are going to be parallel vectors. Okay, they lie on top of each other. They clearly have the same direction. They don't have the same length, but they do lie on top of each other. The angle should be 0 degrees between them, but we need to make sure. Okay, so we do have to go through the process of finding the dot product, figuring out the magnitudes, and then applying the formula here. Okay, so let's do the dot product first. So the dot product, if we do V dot W, this is going to be 3 times 9 plus -4 times -12. Okay, so let me write it this way. All right, this is going to be 27 plus 48. This is going to give me 75. Okay, so that's the dot product. Now I need to get the magnitudes. Okay, so the magnitude of V, we need to go to V. We need to square the components. So we're going to have 3 squared, -4 squared. Add these guys up. Take the square root. So this is going to be the square root of 9 plus 16. This is going to be the square root of 25. The magnitude of vector v is 5. Do the same thing for w. Okay, we need to go to vector w. We need to square the components. So we're going to get 9 squared. We're going to get negative 12 squared. We're going to add that up, take the square root. So we're going to get the square root of 81 plus 144. Okay, let's see what that gives us. If we do 81 plus 144, okay, that's going to give us 225, and the square root of 225 is 15. Okay, so the magnitude of vector w is going to be 15. Okay, we can go ahead and put this into our formula. Okay, so the cosine of theta is going to be equal to v dot w. Okay, that's going to be 75 over the magnitude of v, which is 5, times the magnitude of w, which is 15. Okay, so this is going to tell us that if we want theta, it's going to be the, well, let me erase this. Theta is going to be the cosine inverse of this quantity. Okay, this is what we need to go to the calculator and check out. Okay, 5 times 15 is 75. Ooh, look at this. So this is going to be the cosine inverse of 1. Okay, if we go to the calculator and we do cosine inverse of 1, that's going to tell us that the angle between the two vectors is 0 degrees. Okay, so they are indeed parallel. Okay, so just remember, if you use the formula, cosine of theta is equal to u dot v over the magnitude of u times the magnitude of v, you can use that formula to figure out the angle between your vectors. If the angle is 90 degrees or pi over 2, that means you're dealing with orthogonal or perpendicular vectors. If instead the angle between the vectors is 0 degrees or 180 degrees, that means the vectors are going to be parallel. If the angle is something else, if it's not 90 degrees, it's not 0 degrees, it's not 180 degrees, then the vectors are neither parallel nor perpendicular.